You know, right now, as you're watching this explainer, you're likely holding an absolute miracle of modern engineering right in the palm of your hand. We rarely give it a second thought, do we? But just beneath that sleek glass and metal exterior of your device lies this invisible, glowing world. It's literally a highly efficient microscopic power plant silently churning away, bringing the digital world to life. So today, we're going to explore the precise, honestly beautiful mechanics of the lithium-ion battery.
Seriously, have you ever actually stopped to wonder what's happening inside your smartphone the second the screen lights up? Or think bigger, how a massive electric vehicle propels itself down the highway in near total silence? Well, it isn't magic. It's a literal, microscopic journey of particles, a perfectly choreographed chemical dance that's taking place millions of times a second.
Section 1. Anatomy of the battery.
Let's dive right in and strip away the outer casing of a standard battery cell. To really understand this, we need to scale way down to the atomic level to examine the foundational architecture of the tech. At its absolute core, what actually is a lithium battery? By definition, it's a device that stores electrical energy chemically and then releases it as electricity the exact moment you need it. Basically, it takes the electricity from your wall outlet, locks it away in a highly stable chemical state, and seamlessly translates it back into an active electrical current to power your life on the go. Let's meet the cast of microscopic characters that make this energy translation possible. Think of this like looking at a futuristic blueprint. A typical lithium-ion cell really relies on four major parts. First up, the anode. That's the negative terminal. Usually made of graphite, you can think of it as a storage facility that holds onto lithium ions. Opposite the anode is the cathode, the positive terminal, which is crafted from lithium metal compounds. Sitting right between them is the electrolyte. This is a chemical gateway, usually a liquid or gel that allows lithium ions to physically move back and forth. But they can't just mix freely. That's where the separator comes in. It's a remarkably thin, absolutely crucial layer that physically keeps the anode and cathode apart to prevent catastrophic short circuits, all while remaining porous enough to let those microscopic ions slip on through.
Section 2. The discharge process.
Okay, so we've got our structural blueprint, but how does it actually generate power? Let's zoom in a little closer and witness the literal commute of these particles. The discharge process is just a masterclass in controlled chemistry. The moment you turn your device on, step 1 kicks off. Lithium ions detach from the graphite anode and migrate across the battery over to the cathode, swimming right through that electrolyte. But here's the clever trick. Every single time a lithium ion makes that journey, it leaves an electron behind. In step 2, those abandoned electrons desperately want to reunite with their ions at the cathode, but they are completely blocked by the separator. No way through. So the only way for them to get to the other side is to take a massive detour. They're forced to travel out of the battery and through an external circuit, literally the internal wiring of your device. Step 3 is the payoff. That massive forced migration of electrons rushing through your device, that is the electric current that lights your screen and powers your world.
It really all comes down to one simple, unshakable rule. Inside the battery, the physical lithium ions are moving. Outside the battery, the electrons are moving through the wires. By separating the path of the ion from the path of the electron, engineers have brilliantly harnessed a natural chemical reaction and turned it into a hyper-reliable engine for portable power.
Now, looking at the pure science of it, the basic chemical idea is represented by this super simple equation. Li becomes Li+, plus an electron. The entire lithium-ion industry exists because lithium atoms possess a really unique fundamental trait. They very easily lose and gain electrons. At the anode, during discharge, the lithium atom splits. The positively charged ion heads through the battery, while the negatively charged electron heads through your device. It's a microscopic division of labor yielding immense technological power.
Section 3. The recharging process.
Of course, eventually your battery hits 0%. When you plug it into the wall, we enter the recharging process, which is essentially forcing that chemical dance to play completely in reverse. Step 1. Your wall outlet provides an external power source that forcefully pumps electrons right back into the battery's anode. Because the electrons are gathering there, step 2 happens. The positively charged lithium ions are magnetically drawn away from the cathode. They swim back across the electrolyte, pass through the separator, and embed themselves safely back into the graphite anode. And step 3 completes the cycle. The active electrical energy from your wall is perfectly converted back into stored chemical energy, just waiting for you to start the whole process all over again.
Section 4. Why lithium dominates.
Now that we understand the atomic mechanics, we kind of need to pull the camera back a bit. There are dozens of battery chemistries out there. Lead acid, alkaline, yet lithium has absolutely conquered the modern world. Why? Well, the answer lies in a really delicate balance of engineering trade-offs. Looking at the advantages, lithium-ion tech packs a tremendous amount of power into a very lightweight footprint. They're rechargeable thousands of times, have low self-discharge, and they accept fast charging seamlessly. But the disadvantages are very real. These batteries can overheat dangerously if they're physically damaged. Also, the internal chemistry naturally degrades over time, which is exactly why your older phone just doesn't hold a charge like it did on day one. And fundamentally, they require incredibly complex manufacturing, making them pretty expensive compared to the older types.
Section 5. Safety and Modern Applications.
Even with those costs and the gradual degradation, the incredible energy density of lithium means it is definitely here to stay. Let's look at how this microscopic engine is currently being applied on a massive scale. It's the beating heart of our smartphones and laptops. They provide the massive thrust required for electric vehicles. They act as vital grid-level solar energy storage systems. They keep drones hovering, provide immense torque to heavy-duty power tools, and keep our smartwatches ticking. The sheer scale of application here, from a millimeter-thin wearable all the way to a ton-heavy car chassis, is just staggering.
But as you might guess, with that incredible power comes some significant responsibility. Because lithium batteries contain such a high density of stored energy, they do pose an intense safety risk. If a cell is punctured or overheats, the liquid electrolyte can ignite, leading to something called thermal runaway. Because of this, you will almost never find a bare lithium-ion battery in a modern device. They are universally paired with Advanced Battery Management Systems, or BMS. These are dedicated microcomputers whose sole job is to monitor and control the temperature, voltage, and charging speed in real time. This invisible safety net is exactly what allows us to safely carry these dense energy packages around in our pockets every single day.
We started by looking at a simple device in your hand and journeyed through the microscopic flow of ions and electrons that makes it all possible. Lithium-ion technology has fundamentally transformed the way humans interact, travel, and harness energy. But innovation never stops, right? Researchers are already out there working on solid-state batteries and even faster charging architectures. So the next time you unplug your device, I'll leave you with this to ponder. As this invisible chemical dance continues to evolve, what new limits of portable power will human ingenuity break next?
Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more content on engineering, science, aviation, space technology, and the innovations shaping our world. What topic would you like to see next? Let us know in the comments below. Until next time, stay curious, keep learning, and keep exploring. Thanks for watching, and I'll see you in the next video.